Today, I'm going to be creating an AI-powered quiz game. By using AI, this game will be able to create interactive quizzes on anything we can think of, rather than being restricted by fixed topics. You could already use tools like ChatGPT and Microsoft Copilot to generate you a list of questions and answers. The questions could be generated as a list in free text format. However, we want a quiz game that can generate questions and answers using AI and provide a user interface to answer and score those questions. Now, let's take a look at how we can build this. First, we need to create an AI service. This will provide the functionality to generate content based on a prompt. In our case, we'll be generating a list of questions with associated answers. We want to deploy something local on our own laptop so that we aren't relying on third-party cloud software, and we can deploy it for free using open source software. Once we have the AI service running and have it tested in isolation, we need to figure out how to configure it so that it can be integrated directly using a user interface, such as the one we'll be using on our quiz game. Finally, once we're satisfied that it's deployed and can be accessed via other systems, we need to build the user interface that will let us select topics, display the questions, allow us to interactively answer those questions, and score our performance on the quiz. Let's get to it. Python is a language that's commonly used for AI development, and that's what we'll be using on this project. To support our development, we'll be using the Llama framework for building and running models locally. Once Llama has been installed, we can access it through our command line. The first thing we need to do is download a model and test it out. Now we've downloaded a model, we can run it in the command line and start asking it questions. It turns out the model we downloaded needs more memory than what's available on my laptop, so let's try using a less demanding model that should run okay. There we go, it's running now, so if we enter a prompt into the command line, we should see a response come back through. Now that seems to be working, let's see if it can generate us some questions and answers. And just like that, we've now got an AI service that's running locally and can generate questions and answers. However, the user interface isn't so user-friendly, so let's move on to configuring this to allow a better looking UI to use it. We can do this by wrapping our AI service with a REST API. Python has libraries for this, such as Flask and FastAPI, and for this I'll be using Flask. So let's start by creating a Python script which can run a simple prompt similar to before. Now that gives a good response. It took a little while, but maybe we'll take a look into performance later. Now we can talk to our AI language model through Python. We need to create the web API wrapper that will allow questions to be asked from different software applications, such as our UI that we're going to build later. Let's do this now. Now you can see we have a Flask server set up with the endpoint ask question. Let's run this and give it a try. To test out our server now it's running, I'm going to use a piece of software called Postman. Postman is a REST client tool that will emulate how the request will eventually be sent from the user interface that we develop later. As you can see, we've received a successful response with the answer to our question. Now, we're able to successfully call our AI service that's constantly running in the background from another application. However, we want to simply provide a topic rather than a question, and it return a series of questions and answers based on that topic. As you can see, if we provided just a topic at the moment, we still get a long paragraph describing what that topic is rather than specific questions. So what we need to do is make changes to our Python code so that it returns the response in the format that we want. By using a combination of the Alarma library and the Pydantic library within our Python script, we're able to structure and specify the format of the response from the language model. As you can see, once we call the same endpoint request again, the response is now in a JSON format that can be consumed by our user interface in the next step. Now it's time to move on to the final part of this project, the user interface. I'll be using the Flutter framework to develop the web UI for this project. I first started by preparing a very basic web application that tests the core functionality required, that it can integrate with the back end and display the response on the front end. With that now working, we need to make changes to the front end application. Instead of displaying the response as raw text, we need to use the response to automatically generate a series of interactive questions on the UI that the user can answer. With the core functionality now working as we expect, let's update the UI, refresh the look and feel, and test it out with a few different topics. Throughout testing, I found that some of the answers sometimes didn't make sense. Sometimes there were duplicate answers to the same question, and sometimes there was a question with no answers at all. If I was to look at fixing this and making it more robust moving forward, I'd start with experimenting with different models. Models such as DeepSeek R1 or some of Google's Gemma models would be a good starting point. However, this is where we're going to leave it for this video. You can find the code for this project in the GitHub repo linked below. Keep an eye out on the channel for more projects in the future.